So the ratio test suggests that if you have some sort of a subscript n series, you can take a subscript n plus 1 over a n, take the absolute value of that and find the limit as n goes to infinity. If you get a value that's less than 1, your original series will converge. If you get a value that's greater than 1, it'll diverge. And if you get a value that is equal to 1, then the test is inconclusive and you'll have to use a different test. And when do you use ratio test? Well, if your series has factorials in it, that's a dead giveaway that you should use the ratio test. Or if it has a product of like many exponentials, that's also another giveaway for when you have to use the ratio test. Well, you can use other tests too, but the ratio test is very clean to use. And you don't have to do a lot of hypothesis checking or anything like that. It's just finding the limit as an plus 1 over an goes to infinity. So let's look at the example of the series 2 to the k times k factorial over k plus 2 factorial. So we're going to write out the ratio test for this since we have a lot of factorials. We're going to take the limit an plus 1 over an and plug in the an plus 1. So well, in this case it's k, so it's 2k plus 1 times k plus 1 factorial over k plus 1 plus 2 factorial. And here we have to divide it by the original series an. Instead of doing this ugly quadruple division stuff, you can just instead multiply by the inverse, so the denominator over the numerator, like I'll be doing here. Right now I'm just factoring out some stuff to show a clear cancellation that will be happening later on. So as you can see, we can just write it as k plus 2 factorial over 2k times k factorial. And then we get a lot of cancellation going on with the 2k's, k factorial and the k plus 2 factorial. We end up being left with 2 times k plus 1 over k plus 1, and the k plus 1's cancel out too. So we're just going to get the limit of n goes to infinity, well, k goes to infinity of 2, and that's just 2. And 2 is greater than 1, so we get divergence. This example, we have n factorial over 2 times 5 until 3n plus 2. We're going to use the ratio test. Since we have a bunch of factorials, we're going to take the n plus 1 element and divide it by the n element. So we have n plus 1 factorial all over 2 times 5 up to 3 times n plus 1 plus 2. And then we just divide it by an, which is the same thing as multiplying it by 1 over an. And then we can take the n plus 1 factorial and represent it as n plus 1 times n factorial, and then we get a lot of cancellation happening. So then if we rewrite it, it's just going to be n plus 1 over 3 times n plus 1 plus 2. If we get the limit of that as it goes to infinity using previous calculus techniques, you'll see that it's 1/3, and that's less than 1, so we get convergence. In fact, we get absolute convergence. Here's another example where we have multiplication of a bunch of random terms. So we can use our ratio test here, take the limit as k goes to infinity of the ak plus 1 term over the ak term. So we're going to get 1 times 4 until 3k plus 1 minus 2 instead of 3k. And then in the denominator we're going to get up to 2 times k plus 1. And then we're going to multiply that by the inverse. And then we should get a bunch of cancellation. The whole 1 times 4 until the 3k minus 2 gets cancelled, and the denominator also gets cancelled. So we're just left with 3k plus 3 minus 2 over 2k plus 2, and find the limit of that as it goes to infinity. It's just going to be 3 over 2, and therefore it diverges. This example you can do in many ways, but I think the easiest way to do it would be with ratio test. So we're going to take the limit n goes to infinity of n plus 1 over 2 to the n plus 1 and multiply that by the inverse of the original. So we're going to get, if we simplify the 2 to the n plus 1, we're going to get 2 times 2 to the n. That's going to cancel out, so we're going to be left with n plus 1 over 2n. If you take the limit of that as it goes to infinity, it's just going to be half, and therefore it converges. So here's another example. We have negative 3 to the n minus 1 over square root of n. We're going to use the ratio test again. So n minus 1 plus 1 is just going to give us n. And then we have the square root n plus 1 times the inverse of the original. So we can represent the negative 3 to the n as negative 3 to the n minus 1 times negative 3. So the negative 3 to the n minus 1's cancel out. and then we're just going to be left with negative 3 times square root n over square root n plus 1. Take the limit of that, it's just going to be the absolute value of negative 3, which is just 3, and that's greater than 1, so therefore it diverges. Another example, we have k factorial over 3 to the k to the 2. So we're going to use the ratio test. We're going to have k plus 1 times k factorial over 3 to the k plus 1 to the 2, and we're going to divide it by the inverse of the original. So the k factorials are going to cancel out, but then we're going to be left with 3 to the k to the 2 over 3 to the k plus 1 to the 2, which we can't do much about. So the way I'm going to go about this is we're going to expand out the k plus 1 to the 2. We are going to split it up, so we're going to get 3 to the k to the 2 times 3 to the 2k times 3, and that way the 3 to the k to the 2's will cancel out from the numerator, and we're just left with the limit of k plus 1 over the limit of 3 to the 2k times 3. We can represent the 3 to the 2k plus 3 as 9 to the k, and we just have a linear over an exponential. The exponential will go to infinity faster. You can show this with L'Hopital's rule if you want. So we get 0, and that's less than 1, and therefore we get convergence. So the last example here is also a little bit complicated, but we can use the ratio test. So we have our 3 to the k plus 1 over k plus 1 to the k plus 1, and that's going to be multiplied by the inverse of the original. So we can go ahead and factor out the 3 from the 3 to the k plus 1 so that we get cancellation over there, and then we get k plus 1 to the k plus 1, so we can turn this into k plus 1 to the k times k plus 1. And since we can't just do simple cancellation here, what we're going to have to do, we can group the 3 over k plus 1 together, and the k over k plus 1, we can bring that to the common power of k, and we'll see that both these terms actually equal to 0. 3 over k plus 1 goes to 0, and k over k plus 1 also goes to 0, because you have a number in the numerator that's smaller than the denominator. You have exponential decay, and we know that exponential decays goes to 0.